The arithmetic mean, commonly referred to as average, is often the most informative measure of central tendency for quantitative data, and forms the basis of advanced statistical analysis. We will look at different ways of calculating a mean, and when each approach is useful. You will see how the sample mean can stand in for a larger population, and where weighted means become essential. Our focus is not on the mathematics, but on understanding why the mean is considered to be one of the most powerful averages, and forms the basis of advanced statistical analysis and data science. Much like the mode and the median, the mean gives you a single number that summarizes many quantitative observations, such as sales performance or revenues, into something tangible and actionable. It provides an easy benchmark that lets you compare groups, time periods, or different strategies without getting lost in every individual data point. In business, most choices are made under time pressure, so having a clear mean supports quick but grounded trade-offs. Because we rarely have every single observation from a population, we often use the mean of the sample as a practical estimate for the larger group. Understanding what that mean can and cannot tell you is central to responsible decision-making. One of my favorite memory hacks for the mean is a funny line about how mean refers to average. Remember that when you say average, most people will assume you are referring to the arithmetic mean. This is one of the reasons why it is essential to use the correct terminology when communicating. Mean equals average, median equals typical, mode equals most often. When others use the term average, always cross-check to ensure that their usage and your understanding are about the same metric. When we calculate a sample mean, we are treating that sample as a snapshot of the wider population we care about, such as all costs or all revenues or all customers or all employees. The mean tells us where the center of that snapshot lies, so we can speak about what the average individual value hovers around. For instance, with the 30 client ages in the example, the mean age acts as a single understandable headline about that pilot group. At the same time, we should always ask how that sample was created, because a mean from a very unusual or biased sample might not represent the broader population well. Mean values are impacted by outliers and extreme values in the sample. Accounting for these outliers by investigating them before further analysis can make a big difference in the story you think the sample data is telling versus the true population story. When we work with the raw data, every single observation is included in the calculation of the mean. That makes the mean as accurate as possible for that specific sample, because no detail is lost by grouping or summarizing. A well-constructed frequency distribution is also a reasonable way to calculate the mean accurately. In business reporting, this approach is helpful when you need a regular summary, such as daily age distributions or score distributions, without dealing with every single row. It makes reporting more efficient while keeping the mean meaningful for decisions. With grouped frequency distributions, values are placed into buckets or ranges. We then use the midpoint of each group as a stand-in for all values in that range when calculating the mean. This is where we clearly trade some accuracy for efficiency, because observations at the edges of each group are treated as if they were at the center. In small samples, this can shift the mean a bit more, but in very large datasets, that loss of precision is often acceptable. For business leaders, the key is deciding when the speed and simplicity of grouped data outweigh the small difference from a fully detailed calculation. The method you pick for calculating a mean should align with the importance and sensitivity of the decision you are making. When samples are small, or the decision is high stakes, such as making a policy based on a single class, the raw data mean, or at least the frequency distribution, is usually preferable. When you are dealing with huge volumes, such as thousands of customers per day, grouping into ranges to find a mean can make analysis far more practical. What matters is being explicit that a grouped mean is an approximation, especially when you are explaining results to others, or are trying to interpret results presented to you. This awareness keeps conversations honest about both the power and the limits of the average you are using. A weighted mean is used when you already have several means for different groups and want a single overall average. Instead of simply averaging those means, you give each one a weight that reflects its sample size, so bigger groups influence the final number more than smaller ones. Without this weighting, a tiny group would count as much as a large one, which would distort the overall picture. In business, This is crucial whenever you combine averages across departments, branches, or sections, such as average test scores from multiple classes. The weighted mean lets you tell a fair story about the full population represented by all those groups together. To reiterate, the actual formulations of weighted means are less important than making the determination on whether you want to use them or not. Outputs and calculations can be easily generated for large samples with software or AI tools, but the interpretation and usage of those outputs depends on your ability to identify what matters and what does not. Beyond the calculation, the real value of a weighted mean lies in how you interpret it. It tells you the overall level across all groups, but it also invites questions about which groups are pulling that average up or down. For example, in our illustration for weighted means, the first cohort is bigger as compared to the others and has a higher average to begin with. This implies that it might have more pull on the final weighted average of 82. Recognizing that influence helps you decide where to focus improvement efforts or additional support. In business terms, weighted means guide strategy by making clear which segments truly shape overall performance, rather than treating every segment as equally important by default. Across our examples and discussion, the core message is that how you calculate and interpret a mean should always match the business context and the decision at hand. The mean of a reasonably chosen sample often serves as a useful stand-in for the population, especially when data collection is limited by time or cost. When you summarize or group data, remember that you are trading precision for efficiency, which may be acceptable or not, depending on your purpose. Weighted means become critical when you combine multiple groups, because they respect the true impact of different group sizes. Bringing these ideas together, you can use means not just as numbers, but as clear, reliable headlines that shape smarter, data-based decisions.